So the video on limiting reactants was already getting crazy long. I'll be surprised if anybody actually makes it to the end of that video. So I didn't want to address percent yield in that video, even though that was my original intention, because it was just way too long. So I'm just going to make a quick video on percent yield, and I'm just going to go over one problem to show you how we figure it out. So the first thing you need to know about percent yield is that there's a formula to figure it out. And so the formula for percent yield is, so percent yield is equal to your actual yield divided by the theoretical yield times 100. So you need to know the difference between actual yield and theoretical yield. So theoretical yield is the amount of product in grams, so the amount of product possible as calculated through stoichiometry. So it's how much, if a reaction went perfectly, if you measured out the exact amounts, there were no contaminants, everything went perfectly, how much you could produce of something in grams. The actual yield is the amount that you actually produce. So this is what we get from measurements. So you would actually do a reaction in a lab, measure how much you produced in grams, and that would be your actual yield. So let's take a look at a problem. So 1 gram of H2 is allowed to react with 10.3 grams of N2, producing 2.61 grams of NH3. What is the theoretical yield and what is the percent yield? So this problem in itself, before you can actually figure out what the theoretical and percent yield are, it's a limiting reactant problem. And you notice in this problem, we're not given a chemical reaction. So we have to come up with the chemical reaction ourselves. So we're told that a certain amount of H2 is allowed to react with a certain amount of N2, and that produces a certain amount of NH3. So this is our reaction. Now the second step is to figure out, is this reaction balanced? Let's just do our little bookkeeping method here to figure it out. So we have hydrogen and nitrogen on both sides. On the left we have 2 hydrogens and 2 nitrogens, and on the right we have 3 hydrogens and 1 nitrogen. So the first thing I'm going to do is I'm going to try to balance the nitrogens. So I'll put a 2 in front of here, which gives us 2 nitrogens, but remember, this 2 also affects this 3, so we have to multiply, and that changes our hydrogens to 6. So now our nitrogens are balanced, but our hydrogens are no longer balanced. So if I have 2 hydrogens on the left, what coefficient can I put in front of here to give 6? Well, I can put a 3, and 3 times 2 is 6. So now we have a balanced reaction. And just like in all the other problems we go over, I like to identify what it is that we're given. So we're told we have 1.90 grams of H2. So I'm going to write that under here, 1.90 grams. We're told that we also have 10.3 grams of N2. So 10.3 grams of N2. And we're told that these two together produce 2.61 grams of NH3. So I'm going to write 2.61 grams. Okay. So now the first thing that we need to do is figure out what is our limiting reactant, because that's going to tell us the maximum amount of NH3 that we could produce. So I like to take the method where we take our 2 reactants and turn them into the product. So I'm going to take our grams, I'm going to try to figure out this many grams of H2 produces how many moles of NH3, and also this many grams of N2 produces how many moles of NH3. So let's start with H2. So we're told that there are 1.90 grams, and the first thing I need to do 1.90 grams of H2. And the first thing we need to do is convert this to moles of H2. So in 1 mole of H2, there are 2.02 grams. Cancel out our units. Grams cancels with grams, and we're left with moles of H2. So this comes out to be 0.9405 moles of H2. Okay, now we need to convert this moles of H2 to moles of NH3, and we do that by using the molar ratio. So the molar ratio says that there is 2 NH3 over 3 H2. Now if we cancel out our units, H2 cancels with H2, and we're left with moles of NH3. So when you put this into your calculator, you should get 0.627 moles of NH3. Okay, so this is how many moles of NH3 are produced from this many grams of H2. Now I'm going to do the same exact thing, but with N2. So 10.3 grams of N2 converted to moles. So 1 mole over 28.02 grams. Let's cancel out our units. Grams cancels with grams. And left with moles of N2. So that comes out to be 0.3675 moles of N2. Now I'm going to convert this moles of N2 to moles of NH3 using the molar ratios. So again, 2NH3 on the top because that's the unit that we want to retain, over 1N2 on the bottom because that's the unit that we want to cancel. N2 cancels with N2 and we're left with moles of NH3. So when you put this into your calculator, you should get 0.735 moles of NH3. Okay, now we're comparing sandwiches to sandwiches because we have moles of NH3 and moles of NH3. So if you look at these two numbers, which one's smaller? This one right here is smaller. So this is the maximum amount of NH3 that can be produced. Which reactant produced this amount? H2. Since H2 was the reactant that produced this amount, that means H2 is our limiting reactant. Now, what we have to do is we have to take this amount of NH3, this 0.627 moles of NH3, and turn it into grams of NH3, and that will give us our theoretical yield. Since we know that this is the maximum amount of NH3 that we can produce, we don't care about this number anymore because we don't have enough ingredients to produce this number. So we're not going to go any further with it. We're only going to look at the maximum amount of NH3 which can be produced, which is dictated by our limiting reactant. So we're going to come down here and take this 0.627 moles of NH3, and we're going to convert it to grams of NH3 because our percent yield formula, the numbers have to be in grams. So we convert this to grams by 1 mole goes on the bottom because that's what we want to cancel, and the molar mass of NH3 is 17.04 grams. So moles cancels with moles, and we're left with grams of NH3. So when you put this into your calculator, you should get 10.7 grams of NH3. So this number right here is our theoretical yield. This is how many grams of NH3 we can produce based upon the amount of moles that can be produced from our limiting reactant. So if you remember, the formula for percent yield is actual yield divided by theoretical. So the actual yield is what we're given in the problem. So we're told that this many grams is what was actually produced. And here we have how many grams should theoretically be produced if this reaction went perfectly. So what we do is we take our actual, which was 2.61, and we divide it by the theoretical, which is 10.7, and we multiply that by 100 because this is a percentage. And when you do that, the answer comes out to be 24.4%. So that is your percent yield, which is an absolutely horrible percent yield. Your percent yield, the closer to 100 it is, the better. 100 meaning it's a perfectly pure substance, and then any number over or under 100 means that there's some kind of contaminant present, or something else went wrong where the substance is not pure. So that is how you figure out a percent yield question. So it's really a limiting reactant question built in, and you just take it one step further, and that leads you to percent yield.